Let's begin. Today is December 2nd, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 7, 8, 14, 16, 21, and 22. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our last digit, the circle digit, and the Turing machine will let us know whether its value is an even digit or an odd digit. Criteria card B will take a look at the 3-digit solution, and the Turing machine will let us know how many ones there are. Are there no ones? Is there a single one? Perhaps 2, maybe even all 3 are 1. Criteria card C will take a look at our 3 digits, triangle, square, and circle, and the Turing machine will let us know which one is the absolute smallest. Should triangle be the smallest? Should square be the smallest? Or should circle be the smallest? Criteria card D again takes a look at our 3-digit solution, but this time it'll let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card E again takes a look at our 3 digits, and the Turing machine will let us know a little bit about its structure, so to speak. Generally, there are 2 cases, one where the 3-digit solution has a pair, as in the example 131, or alternatively, there are no pairs, but there are 2 different scenarios, one where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F again takes a look at our 3-digit solution from triangle to square to circle, but this time it'll let us know a little bit about the order of the digits. Should the digits appear in an ascending order, meaning that they are increasing, as in the example 135, or should they be in a descending order, or basically decreasing, as in the example 421, or it might be that the 3-digit solution has no order. So let's take a look at the 3-digit example of 231. Notice that it goes from 2 to 3, meaning it's increasing, and then 3 to 1, meaning that it's decreasing. And of course, you could have a code that is decreasing and then increasing, but really it's that shift from one direction to the other that can define a 3-digit code as having no order. Now, we have seen in previous puzzles where if you have consecutive equal digits, that also can represent no order. For example, if we take a look at this code of 112, notice that when it goes from 1 to 1, there is no change. There is no increase and no decrease. And so that is another way, as I stated, to represent a code as having no order. Now remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card A. Okay, so the Turing machine approves of my choice in circle. Notice that I did pick an even 4, and the Turing machine confirms that yes, that circle digit should be even. So let's go ahead and type that up in our notes in section A, and we'll say that circle is an even digit. And of course, since that circle digit is even, let's go ahead and cross out the 3 odds. Okay, so I think the next thing I'd like to test is criteria card D. Okay, so the Turing machine does not approve of my choice in proposal 314. Notice that I do have 2 odds to a single even, but since the Turing machine does not approve of that, it's actually letting us know that there actually should be more even than odds. So let's go ahead and type that up in our notes in section D, and we'll say that there should be more even than odds. Well, now that we established previously in criteria card A that circle is even, and we do have a majority of evens, we know that at least one, if not both, of triangle and square must also be even. So either we're looking for an all-even solution or 2 evens and a single odd. And we do have this criteria card B letting us know how many ones there are. So at this point, there's either a 1 or not. But just because a 1 does not appear does not mean that the digit is either 3 or 5. We still don't know which one is. We still don't know if we're dealing with an all-even solution or 2 evens and a single odd. I think the next thing I'd like to test is criteria card C. Okay, so for criteria card C, we're identifying which is the smallest. In my proposal, I have square to be the smallest, but since the Turing machine does not agree with that, that means that either triangle or circle must be the smallest. So let's go ahead and type that up in our notes in section C, and we'll state it as either triangle or circle must be the smallest. And let's see, is the smallest. Okay, and let's see, well, what can we say? Well, I think we can say that since square cannot be the smallest, it can't be a 1. Because if square were 1, there wouldn't be, there couldn't be an absolute smallest in either triangle or circle. So triangle or square cannot be a 1 for that fact. And let's see, can we say, we can still have triangle be a 5. That's okay because circle could still be the smallest, but we can't just outright cross it out, I don't think. Let's see. Yeah. Okay. And triangle could be a 1. So I don't think we can cross out anything else. Okay. All right. Well, I think that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card B, again identifying whether we have a 1 or not. And we didn't, although we tested C, we still are not sure which of triangle or circle might be the smallest. And we didn't test criteria cards E or F, but if you recall from previous videos, we have been able to deduce both of them. So let's do this. So the argument for criteria card F is as follows. If you presume that the solution is ascending, by definition, that means that all of the digits must be unique. You can't have any kind of duplicates in there. So therefore, if it is ascending, you would know that the 3-digit solution would also have no pairs, making this card irrelevant. And likewise, if it's descending, we know that they are uniquely getting smaller, and again, having no pairs, making criteria card E irrelevant. So for that fact, we can say that the solution, we're going to deduce that the solution has no order. Okay, and we're going to make a similar argument as to if we presume the solution to be a pair. Well, as I discussed at the top of the video, if you have a pair, whether consecutively, consecutively, meaning that they're next to each other, or even if they are separated as 131 by that middle digit, that would mean if you had a pair, that would mean that your solution has no order. So again, making criteria card F now irrelevant. So for that fact, we're going to deduce that there are no pairs in our solution. I apologize, I am experiencing a little bit of lag. But again, yeah, so the solution has no pairs. Okay, so that stated, we know we can't have any pairs and there's going to be no order. So the question is, could there be a 1? And again, we'd have to probably retest criteria card C. So, and we do have a majority of evens. So let's say if we said that there is a single 1, well, it would default down to triangle, and then triangle would be our smallest. So that would mean it would be 1, and then we'd have evens in 2 and 4. And so what that would mean is, based on the no order, it would have to be 1, 4, 2. Now that's if you do have a 1. So let's see. So yeah, it would look like to be 1, 4, 2, but that might be too simple of a solution. So what if there were no 1s? Then we would have either a 3 or a 5, and we would still have to somehow order our digits. We would also have to know which one is the smallest among triangle and circle. So it would seem that So also remember, because we have no duplicates, we uniquely have 2 and 4, because we do have a majority of evens. So we do have a 2, 4, and the question is that other odd going to be 3 or 5? So yeah, so 1, 4, 2, but if there are no 1s, somehow we have to order these digits. So it would seem that since we have a majority of evens, let's pretend that square is the even, making triangle the odd. So if we pretend triangle is odd, square is even, and square cannot be the smallest, remember. So if triangle's odd, that would mean that square would have to be 4, and then circle would be 2. So then we're looking at 3, 4, 2. So yeah, 3, 4, 2, and previously we said 1, 4, 2. Okay, 342, 142. That's if triangle is the odd. If triangle is even, though, what would that mean? That would mean that square would have to be odd. And remember, we can't have duplicates. So it's either going to be a 3 or a 5. But again, square can't be the largest, so that would mean that it would have to be a 3. And I don't think that's going to be possible, because if square cannot be the biggest and it's odd, it's 3, I don't think there's a way you can have to use 2 and 4 so that it's not, so that it has no order. It would either be 2, 3, 4 or 4, 3, 2. So yeah, so I think we're going to have triangle be the odd. Now the question is it 1 or 3? And it seems like we're going to have 4, 2, either 1, 4, 2 or 3, 4, 2 as a solution. And probably the best bet is to test that one value. So let's go ahead and choose 1, 4, 2. And I think we only have to test whether there's a 1 or not. Okay, so just to double check, is that last digit even? It is. Are either triangle or circle the smallest? Well, I chose triangle to be the smallest, so that's okay. There are more evens, and no pairs, and no order. Okay, and I think what we're going to do is we're going to test whether there is a 1 or not. So let's go ahead and test criteria card B. Okay, so there is no 1. So let me go ahead and type that up. Right, the Turing Machine does not approve of the presence of 1. So yeah, so there are no 1 digits. So let's go ahead and type that up, and we'll say that the solution has no 1 digit. So let's go ahead and cross out the 1 in triangle. And remember, we do need to have an odd. And can we have, well, yeah, and square cannot be the smallest. Remember, square cannot be the smallest. So square can't be a 2, because if square were 2, there's nothing for triangle and circle to be smaller than. Okay. And so we can't have duplicates. So again, we're down to, can triangle be 5? Well, I don't think triangle could be 5, because now you're left with 5, 4, 2. So no, triangle can't be a 5. Square could be 5. Oh, I had not considered. Oh, wait. Square can't be the largest again. Wait, did I do that right? Hold on. It's the smallest. Yeah, square can't be the smallest. So square could be larger. I guess I had not considered 2, 5, 4 as a possibility. I may have been confusing how C was working when I came up with the proposals. So yeah, you could have 2, 5, 4. That is still, I guess, again, I had not considered that possibility. Okay, so we are dealing with either an odd. Yeah, so we crossed out the triangle 5, because that would mean, let's see, yeah, square could not be the smallest, So it can't be a 2. So if triangle were 5, yeah, that would mean we'd have a descending, so that's why we crossed out triangle 5. Okay, so let's see, if circle is a 2, that would mean that triangle would have to be 3, so you'd have 3, 4, 2, which is one of the original possibilities. So I guess it comes down to, is triangle the smallest or circle the smallest? 3, 4, 2. Can triangle be 4? I don't think triangle could be 4 either, because then that would lead us to, no, it could be 4, 5, 2. Yeah, no, I think that's still, triangle 4 is viable. How about triangle the smallest as 2? 2, 5, 4. Yeah, I think I'm just going to have to retest C and see which one is the smallest. Yeah, I don't think I can deduce, because you do have 2, 5, 4, 3, 4, 2, 4, 5, 2. Yeah, those are all. Well, let me type all of the possible solutions, because maybe there is an ambiguous solution. So if triangle is to be the smallest, it could be a 2, and then square would have to be odd, meaning it'd be 2, 5, 4. So you have 2, 5, 4. And that's if triangle is the smallest with a 2. Yeah, because it can't be 2, 3, 4. That would be ascending. How about, and it can't be 2, 4, because you can't have duplicates. So yeah, 2, 5, 4 seems to be the only possibility with triangle 2. If triangle is 3, it could be 3, 4, 2. Three, 4, 2, yeah, that's viable. And it could be 4, 5, 2 as an alternative to that. So both 2, 5, well, no, let's see. We do have a case where circle is the smallest with a 2. Okay, is there any way to distinguish? That is, circle is the smallest. Can I distinguish 3, 4, 2 from 4, 5, 2? Well, the last one is even, yes. There are no ones. We're basically deducing that circle is the smallest. There is a majority of evens. There are no pairs, and there are no order. And I believe all of them do exhibit no order, increasing, decreasing, increasing, decreasing, and increasing, decreasing. Yeah, so it looks like I don't see a distinction between 3, 4, 2 and 4, 5, 2. Yeah, circle is the smallest. So I'm going to cross these out and say that these are ambiguous. I don't see any distinction where circle is the smallest. So I think we can deduce that circle can't be the smallest, because that would produce ambiguous solutions. If circle is the smallest, 4, 5, 2 and 3, 4, 2, yeah. So it looks like our solution should be 2, 5, 4. where circle is the smallest, 2, 5, 4. Now obviously 4 couldn't be the smallest. Could 3? 3, 4, 2. Hold on. Oh, wait. Oh. No, yeah, 3, 4, 2. 3, 4, 2. Yeah, but 2 is still the smallest, so you could have picked 3. 3, 4, 2. And 4, 5, 2. Yeah. So, I wouldn't say triangle 3 would be the smallest per se, because it would still be 2. Yeah. So it looks like, 2, 5, 4 should be the answer. Yeah. Okay. Well, let's go with it and see what the Turing Machine says. 2, 5, 4 as our solution. So 2, 5, 4. And let's see how we do. Okay, yes, fantastic. Well, how do we do versus the Turing Machine? Well, it is a 6 criteria card puzzle, and we did it in 4. So that's promising. We did A, C, D in the first round, and A was the only correct one. We only had to do B in the second round, and we outright deduced E and F. So let's go ahead and type that up. A, C, D in the first round. A was correct. C and D were incorrect. And we only had to test B, and that was also incorrect. So, so we beat the Turing Machine by 2 questions. So, without a doubt, being able to deduce criteria cards E and F outright, the way they interact with each other, we're able to deduce them. And then it came down to, again, because there are no pairs, you had to have an odd. So the question is, was there a 1 or not? And it came out true that there should be no 1s. So, and then we were able to list out the potential solutions and discovered that these last 2 were ambiguous because they both had circle as the smallest, and there was no way to distinguish between them when looking at the remaining criteria cards. So that left with 2, 5, 4 as the only possible solution. Well, how about you? How did you solve it? Did you quite remember those deductions? Did that help out? Or did you choose different criteria cards, and did you discover something interesting that you'd like to share? Add those thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.